Okay, let's turn next to the problem set and let's review some of the concepts related to the normal distribution. And let's begin with the first problem. So the mean life of a pair of shoes is 40 months with a standard deviation of 8 months. If the life of the shoes is normally distributed, how many pairs of shoes out of 1 million will need replacement before 36 months? So whenever you have a problem like this, you typically just draw it first, and we acknowledge that we have a problem where we have a normal distribution, looks maybe something like this, and here we have the life of the shoes in months, and then we write down what we have. So we know we have a mean of 40 and we have a standard deviation of 8, and we want to know what's the probability that the randomly selected shoe has a lifespan of 36 months or less. So that means I want to know this area here to the left, and then we can convert this problem into a z-score. So now we convert everything into a z-score. So we have the same shape of a distribution. But the mean gets a z-score of 0, and the 36 gets what z-score. So the z-score is, we need to ask how many standard deviations is a 36 below a 40 when the standard deviation is 8. And then all we need to do is we subtract from 36 to 40, divide by 8, and then we get negative 0.5. So here we have a 0.5. And this is the area that we need to find. So we can look it up in a table or in Excel. I prefer Excel. So now we need the formula norm dot s, this, because everything is in z-scores, and then our z-score is negative 0.5, and we want it cumulatively, which is the area to it. Okay, so now we get something like 0.30854, but that's the probability. So then, out of 1 million shoes, we still have to multiply that times 1 million. 1, 2, 3, 4, 5, 6. And then we get like 308,538. Okay, so here it is rounded. So, but that's the closest answer. Okay, so now we can delete this. Oops, delete. Okay. Now let's move to the next question. The area under the normal curve between z equals 0 and z equals 1 is blank. The area less under the normal curve between z equals 1 and z equals 2. I think that's pretty straightforward here. So if we draw it, we would say the area between 0 and 1, and we know this is actually 34% from the empirical rule, but just visually this area between 0 and 1 must be greater, so the area is greater than. Okay, so delete all ink. Okay, so values of a standard normal random variables are measured with reference to specific units. No. In the units in which the mean is measured, no. In the number of standard deviations from the mean, that's correct. Okay, so another example, the price to earnings ratio for firms in a certain industry is distributed according to a normal distribution. In this industry, a firm with a standard normal variable value of z equals 1, okay, so it's a positive z-score, so that has an above average price to earnings ratio, and specifically it is 1 standard deviation above the mean. So that's the correct answer. Has a below average? No. Has an average? No. May have an above or no. So the only thing that makes sense is A. If the wages of workers for a given company are normally distributed with a mean of 15 per hour, then the proportion of the workers earning more than 13 per hour is, okay, so if we draw it again, okay, so the mean is 15. Okay, and here we have then the 13. So then the proportion of the workers earning more than 13, well, this is this area here, is greater than the proportion earning less. Yeah, that's definitely true. Is greater than the proportion earning less than 18. No, that should be actually so 18, so 13. So no, that would be less, because 18 to the left, that's more probability mass than everything to the right of 13. So is greater than the proportion earning less, that's definitely correct. Is less than 15%? No, because it must be more than 50%. Is less than the proportion earning more than the average? No, it's more. Okay. Okay, so now let's move to the next question. Let's erase this. The miles per gallon for a mid-size car is normally distributed with a mean of 32 and a standard deviation of 0.8. What's the probability that the miles per gallon for a selected mid-size car would be less than 33.2? Okay, that is similar to what we did earlier, so let's just, okay, let's squeeze it both. So this is, here we have everything in miles per gallon. The mean is mu equals 32, and the standard deviation, sigma, is 0.8. And I want to know what's the probability that a selected mid-size car would be less than 33.2. So our xi is 33.2, and I'm interested in this red probability area. So what we do again, we convert that into our z-scores. So the distribution has the same shape. The mean becomes a 0 in terms of z-scores. The question is, how many standard deviations is the 33.2 away from a mean of 32? So in this case, we would say our relevant z-score is 33.2 minus 32, which is 1.2, over 0.8, and that seems to be, so in the numerator we have 1.2 over 0.8, so we are left with 1.5. So that means we need to look up the area to the left of 1.5. So we can use again Excel for that. So in this case we would say norm as dist z 1.5 cumulatively 1. So the area is 93.39%. So, or 93.32. So the answer is C. Okay, let's move to the next one. The fill weight of a certain brand of adult cereal is normally distributed with a mean of 910 grams and a standard deviation of 5 grams. If you select one box of cereal at random from this population, what is the probability that it will weigh more than 904? Okay, it's just the same over and over again, so let's just draw it again. So here we have everything in grams. We know the mean is 910. And the standard deviation is 5. So if you select one box randomly from the population, what's the probability that it will weigh more than 904? So let's say this is here. So this is a 904, it looks more like a 909. Okay, so now we convert that again into our z-scores. Okay, so we have here the same distribution, but now everything is in z-scores. So again, the mean gets 0 and we have a standard deviation of 1. So how far is the 904 away from a mean of 910? So we calculate the z-score, 904 minus 910 over 5. So that's -6 over 5. That's -1.2. Okay, so we are interested in the area more than 904, so that's the area here to the right, or here. Okay, so now we can use again Excel, and of course if we want to know the area to the right of -1.2, that is the same as the area to the left of +1.2, because it's symmetric. So we can use the formula norm dot as dist, and I just say if I want the area to the right of -1.5, that's the same as the area to the left of 1.2, and again I want it cumulatively, so it's 88.94%. So the correct answer, 88.49, the correct answer is A. You could also look it up in a table. In case you want to do it, you can double check, but I think it's more important to practice Excel. Okay, so for a normal population with a mean of 10 and a variance of 4, the probability that X is 10 or greater is, well, that's of course 50%, right? And that's really irrespective of what the variance is, because we have a symmetric distribution. So we have some kind of a distribution. We know the mean is 10. Well, whatever the standard deviation is, it doesn't really matter. Because it is symmetric, the area to the right, well, that must be 50%. Given the length an athlete throws a hammer is a normal random variable with mean 50, feet and a standard deviation of 5 feet. What is the probability he throws it between 50 feet and 60 feet? Okay, so as always we draw it. So here we have everything in feet, and that's the distribution of the athlete. So we know the mean is 50. And the standard deviation is 5. What's the probability that he throws it between 50 and 60 feet? So let's say xi is 60. So then I want to know this area. Again, convert it again into z-score. So the mean becomes 0. What matters is the xi. That gets a z-score of C. So the z-score is ci equals 60 minus 50 over sigma 5. So that's 2. So I need to find the area between 0 and 2. Okay, so let's use Excel again. We use again norm.s.dist. Okay, so now when we say I want the area to the left of a z-score of 2, and again I want it cumulatively because I want the area, well, I get 0.97, but I don't want the area to the left of 0.0 because this one has given us now this entire area. But we need to subtract the 50% to the left of 0. So that means this area needs to be subtracted. So we have to subtract minus 0.5, and then we get 47.72%. And we can actually delete all the... So the answer is 47%. Okay, what is the probability that the random variable having a standard normal distribution is between 0.87 and 1.28? Okay, that's a good question. So we want to know the area between 0.87 and 1.28 on a z-score. Okay, so the best way to do it is to tell Excel, well, first we calculate the area to the left of 1.28. So we would say in Excel norm.s.dist 1.28 cumulatively, but then we subtract minus norm.s.dist 0.87, 1. Right? So first we get everything from 1.28 and then we subtract what's ever left to 0.87. So let's do that. So we would say equals norm dot as dist 1.28 1. Okay, that would be 89%, but now we still have to subtract 0.87. So minus norm dot as dist 0.87 comma 1. Okay, so now we get 9.2% rounded. Okay, that is A. So the next question is that the probability that an appliance is in repair is 50%. If an apartment complex has 144 such appliances, what is the probability that at least 81 will be in repair? Use the normal approximation to the binomial. Okay. So, okay, let's first illustrate the problem. So, what we know is, let's first write down what we have. So we know we have 144, that's our n. We have 144 appliances. And in this case, the success probability is that it's in repair. So the success probability is 0.5. That means that the failure probability is also 0.5. Okay, so the first thing we need to test is the condition, can we actually use the normal approximation to the binomial? And the conditions are that n times p needs to be greater than or equal to 5. Well, that's clearly the case, now 72. And of course, because it's 0.5, we can also write n times 1 minus p equals. So both conditions are met. We can definitely use the standard normal to approximate the binomial. So whenever this is the given, the first thing we want to know, what is actually the mean? So in other words, if we always look at the 144 appliances and you always want to know how many are currently in repair, the mean would be n times p, which is 50% of 144, which is 72. Then what's the standard error? Well, we get that from the binomial distribution, and we know that there the variance is n times p times 1 minus p, but that's the variance or the standard deviation. It's the square root. So now we have the square root of 144 times 0.5, 72, times 0.5, 36. So square root of 36, so the standard deviation is 6. So now this is everything that we know, and so now we have a distribution. It's called the number in repair. So we draw again the standard normal distribution. We know that we approximate the binomial with a normal where the mean is 72 and the standard deviation is 6. And I want to know that at least 81 will be in repair. So I want to know that xi is 81 or greater. So that means we need this probability. Then, of course, when we convert it again into the z-score. So then the mean comes to 0, but the important thing is what is actually the 81. So we calculate the z-score as how many standard deviations is that away from a 72. Okay, so we do, again, the general formula is xi minus the mean over the standard deviation. So that is 81 minus 72, which is 9 over 6. 9 over 6, 3/2 or 1.5. So this is 1.5. And the answer is the area to the right of 1.5, which of course is the same as the area to the left of negative 1.5. So if you use again Excel, you say equals norm dot s dist, and this formula always gives you the area to the left. So I say negative 1.5, which is the same as the area to the right of 1.5, and so we get like 6.7%. So the answer is B. And just for completeness, even though it is not asked, the correct answer, of course, and let's leave it like this. So that's the approximation. But if I want to know that at least 81 are in repair, I would say, I know I use the binom.dist formula, and then the number of successes is cumulatively 80, because I want to know 81 are in repair, so 80, and the number of trials is 144, success probability is 0.5, and yes, I want it cumulatively, but now when I press enter, I get the probability that either 0 or 1 or 2 or 3 or 4 or 79 or 80 are in repair. So in other words, if I subtract that from 1, I get the probability that 81, 82 and so on are in repair. And the answer is 7.8%. So there's like a 1% difference actually, but the 0.78, that would be the true the correct value. Okay, so that concludes the lecture series on the binomial distribution, and yeah, I just hope that I could make everything clear. So thanks for watching.